During the pandemic, researchers like myself who focus on the microbiology of the built environment suddenly found ourselves at the center of attention. Understanding how SARS-CoV-2 may be spreading indoors became incredibly important to ensure we can operate indoors in a safe manner. We now know that SARS-CoV-2 transmits through air in droplets and as particles, and this information has helped us to provide a comprehensive series of advice on how people should manage the indoor environment. Welcome to Editors in Conversation. This episode is brought to you by M-Systems, available at msystems.asm.org. I'm your host, M-Systems Editor-in-Chief, Jack Gilbert. This podcast is supported by the American Society for Microbiology, which publishes M-Systems. Make sure to press the subscribe button wherever you are listening or watching so that you never miss an upcoming episode. I'm joined today in my music room by Leslie Dietz, Patrick Horve, and Dr. van den Wymelenberg from the Biology of the Built Environment Center at the University of Oregon. Leslie Dietz is a research assistant and the lab manager for biology in the Built Environment's BSL-2 laboratory. She obtained a Bachelor of Science from the University of Houston downtown and a Master's of Science from Texas State University. Her background includes molecular biology, genetics, vascular research, along with conservation and ecology, so you can discuss molecules and ecosystems alike. She has been part of the biology of the built environment since 2018, examining the roles and results of microbes in built environments. Patrick Horve graduated from the University of Oregon with a Bachelor of Science in Biology and an emphasis in molecular and cellular and developmental biology. His work has previously included modeling Usher syndrome and other genetically inherited diseases in zebrafish through work with the Undiagnosed Diseases Network. And his research now focuses on understanding the underlying rules and mechanisms that drive the colonization, succession, and establishment of permanent microbial communities in the built environment, and how manipulation of these factors can lead to novel techniques of prevention, intervention, and treatment of microbial-based illnesses. Dr. van den Wymelenberg is a professor at the University of Oregon. He is director of both the Institute for the Health in the Built Environment and Energy Studies in Building Laboratory, as well as the co-director for the Biology of the Built Environment Center in Eugene and Portland, Oregon. He has a PhD in built environments from the University of Washington. His research areas include daylighting design, integrating design principles, energy performance, and air quality, and the microbiome in buildings. Dr. van den Wymelenberg has consulted on several hundred new construction and major renovation projects with architects, engineers regarding energy efficiency and the indoor environmental quality in buildings since 2000. So last year, my guests published a review in M-Systems entitled 2019 Novel Coronavirus COVID-19 Pandemic. Built Environment Considerations to Reduce Transmission. It is published with co-authors David A. Coyle, Mark Fretz, and one of our own senior editors at M-Systems, Jonathan Eisen. This paper was the most downloaded article for M-Systems in 2020 and was in the top 10 most downloaded articles across all ASM journals. This may not be surprising based upon the topic covered. So welcome, everybody. Really excited to have you here. And I wanted to start with you, Leslie. What made you think about putting this paper together?
Well, first, I'll say that it was a team effort. It began about a year ago, February. Patrick, our amazing lab technician, and I were having a discussion about the preliminary reports we were seeing coming out of China. As scientists do, we started to ask questions. Those questions turned into some quick online searches, and we started to find more and more information, not only from China, but from other countries as well. And our questions began to take the shape of the paper that we ended up writing. And our lab is in a unique position to closely examine those kinds of questions and then do some real world experiments as a result.
That's pretty insightful, right? Not many labs were totally set up to take on such an interesting topic. And I mentioned this at the beginning, our lab deals with, microbiology in a built environment in a fair amount. And so we jumped on that bandwagon to a certain extent as well. But you guys got really behind the ball really fast in building out this review, which really, it did cover a lot of the major concepts that we now know are incredibly important. And to me, it involved a certain amount of prescience, right? You had to be ready and you had to be thinking about it. And Patrick, do you want to give us a bit of an overview of what the review covers? So for the listeners and viewers who haven't actually read it yet and who should have read it by now, because it's awesome.
Yeah, absolutely. So pretty early on, we understood that one of the major control strategies that was going to be used to combat the spread of COVID-19 was going to be social distancing and potentially remaining indoors for long periods of time. And so a big part of what we wanted to do was provide some guidance towards the scenario of what if someone in your home gets sick, and what can you do to keep others in that same home from getting sick? But I think this turned even more over time and over the course of the pandemic into how can we protect individuals that aren't able to socially distance and they still have to remain in enclosed spaces, potentially being exposed to the virus. And as Leslie mentioned, we understood that we were pretty uniquely positioned to be able to provide this guidance towards being able to potentially mitigate COVID-19 infections in the built environment. So broadly, the main infection interventions that we wanted to look at were disinfection, environmental modifications, and fresh air. For disinfection, we first wanted to emphasize the importance of hand washing, and really this as the first defense against infections from fomites and other individuals. We also wanted to emphasize cleaning commonly touched surfaces, especially when going out and in your own home when bringing things back in. Secondly, we outlined some previous evidence showing that maintaining relative humidity levels at 40 to 60% could help to inactivate and decrease the amount of viable viruses and especially coronaviruses in the air. And lastly, we wanted to emphasize the importance of better filtration and increasing the amount of outside air that you're bringing into the built environment.
I mean, that all sounds, spot on, right, for controlling coronavirus, which I'm assuming most people should accept and know by now. But it also sounds like common sense. I've worked with ASHRAE, the indoor air people who try and come up with these strategies to provide building groups with these recommendations. And, it always strikes me as everything that we come up with in terms of recommendations are reasonably common sense. So it always bemuses me when architects and building designers and building operators aren't adopting these. Kevin, I'm going to call you Kevin because I'm assuming you don't need me to call you Professor van der Wymelenberg.
No, please.
Tell me why was this revolutionary for architects and building designers, or was this, did most people just accept it as rote?
Well, I think it's one of those, when you have expertise, it seems really straightforward. And if you don't have that expertise, it's novel, right? So once you know how to do something, it's really easy to do. I think that's a little bit of what we were seeing here. The principles of introducing additional ventilation, increasing your outside air fraction. There's three pieces. And, you can say, oh yeah, more ventilation. Okay, well, how do you do that? You can increase your outside air ratio, you can increase filtration, and you can increase the air exchange rate within a room. And you can do various combinations of those depending on what your building's capabilities were in the first place. So, there's always another layer to dig a little deeper. And then the other point I wanted to make is just that, I've been a proponent of passive design strategies for a long time because of energy efficiency. And, we talk about
what are passive design strategies?
Okay. Passive design strategies. Yeah. So this would be what I'll just simply call natural systems. So we want, natural daylight to come into our windows. We want to be able to see outdoors and get the diversity of intensities for our eyes and our circadian rhythm. We like to have connections to nature. There's sort of mental health benefits associated with those things. And oh, by the way, a little ultraviolet irradiation that makes it through its glass, it may also help with this COVID problem, right? And similar from a humidity standpoint and from a natural ventilation standpoint. You know the work well around the diversity of indoor microbial ecosystems when you have ventilation directly from the perimeter, unfiltered. Of course, there are some challenges with that, but creating these diverse microbial ecosystems. And so at the surface, I absolutely agree with you. There are some things here that are pretty straightforward, but then trying to dig just a little deeper and help people understand how to apply them. And put that in the context of, unfortunately, some of the leaders in our community with three-letter initials that are hard to say sometimes because because of the evidence or the information they were providing was all about disinfecting surfaces and not so much about transmission through the air. Emphasis in the public went to other places. It went to, contact tracing, and it went to social distancing, and, it went to hand washing. All of those are good, but let's not forget about air and the place we spend 90% of our lives indoors.
Yeah, right. It's funny, isn't it? And when we can isolate, it's great that we have the ability to stay in a place where we're not going to be exposing ourselves, not acting as vectors. But especially at universities and institutes, we're so used to gathering en masse in large groups, in conferences, in meetings, in daily events, and I don't think I ever thought about it, right? In terms of, prior to coronavirus, in terms of disease spread. Right. Flu, the common cold, other common coronaviruses that are spreading with our population all the time. Is, everyone talks about getting sick on an airplane, or, getting sick when they go to a conference. I always feel a little bit rough when I've, got the third day. What could we learn in the future, maybe, from what the coronavirus has taught us? I will come back to that, because I'm really interested in thinking about how the building operation community, as well as the scientific community generally, could take this as a learning experience, right? But I do want to hear about it. As I said, this was our one of ASM's for all of the journals, or not just for M Systems, for all the journals, one of the most downloaded papers. And it got a lot of interest. It got a lot of critique at the beginning. I was fielding some issues from people, indoor air folks, who were talking about the ramifications or the suggestions in the paper and what they actually meant. So, Leslie, what was the feedback? You're the first author. Your name's on there. You get people telling you off and people congratulating you. I'm interested to hear what happened.
Well, as a co-first author, I was really surprised by the response. I would say that it was unexpected for me. I did not expect it to be what it was. When Patrick and I put it together initially, I had no idea or expectations of what it would become. Scientists, we have a hunger and a thirst for knowledge, and a driving nature to know the how and the why and the mechanistics behind any phenomenon that we encounter. And that was really the driving force of this paper, was the conversation we had and the digging we started doing, just because we're curious. But I do know that to date, this paper has been featured or referenced on nearly 100 different media platforms globally. And as a result, we're busier than we've ever been.
Well, I like that, because people are looking for answers, right? And you had a lot of answers in here. Do you want to talk about the issues that might be associated with air filtration? Because there were some hiccups there earlier on about how we portrayed the virus. And it really does talk to our emerging understanding of the virus, right? The CDC's initial recommendations were this could be spread in droplets. And now we view it as an airborne virus that comes out in actual viral particles. And that changes the paradigm of some of the advice that was provided. I don't know if anyone wants to talk about that.
Well, I can just share, and I'll claim responsibility for the speed at which we drove this paper out to try to make it useful. We learned our lesson, bumps and bruises, in real time. We made an edit related to clarifying factors on filtration, and I'm the building scientist in the room, so this is on me. And we clarified the language. I think early on, maybe we were trying to say, hey, you know what? It's probably not just about droplets. Let's think about the ultrafine aerosols, maybe those submicron particles. And yes, filtration is an important strategy, but let's maybe just not do the one size or the silver bullet solution, or the one size fits all solution, because you can't necessarily upgrade every building to internal central HEPA filtration, right? And so there's likely some microbial trespass to potentially even HEPA filtration, but I know I'll get comments even for saying that now.
You will.
For MERV 13 or the lower MERV efficiency filtrations. And so we were trying to make the point that layered risk reduction is really important. filtration is one important piece, but don't take any one of these recommended mitigation strategies as a standalone silver bullet. That's the point we were trying to make. And I think we did, but we had some cleanup to do publicly in front of everybody.
It's interesting though, because I was fielding off the back of this paper. I was fielding reports from the BBC and various groups in the UK because I'm originally English, now American. But the presence of that claim that we could just boost up HEPA filtration inside the buildings, everything would be fine. Most of the schools in England are in 19th century properties, built in the late 1700s, early 1800s, and there's literally no way they could do that. So there was a scramble off the back of this information to see if they could open schools, for example, by just upgrading the filtration system. And they were like, well, how do we do that? That's impossible. And so I thought that was fascinating when it was actually happening, because it showed to me that irrespective of what we know about how buildings operate and how people use them, we were sitting there talking about places that our children, spend a lot of time in, and teachers and even parents. And we still had no fundamental understanding of how to make those buildings safe, not just during a pandemic. And sorts of what I wanted to get to earlier, flu and common colds. How do we think this information, that how the pandemic has changed our understanding of buildings? And I'll put this to you, Patrick, because I'm interested in your understanding on this. How has the information that we have gained changed how we should be operating buildings in the future? Once this nightmare is over, and hopefully we don't forget it too quickly, but there's seasonal viruses. Now, I'm interested to know what you think people might take from this.
Yeah, absolutely. Like Kevin said, there is no single foolproof strategy, and I think that's the biggest lesson to take away from this. We saw that there's, like we mentioned in our paper, there's a lot of different ways that you can look to mitigate these risks. And as we'd mentioned previously, increasing the filtration can be a big part of this. But of course, even this isn't foolproof. We saw from events like the super spreader event that occurred at the White House Rose Gardens, that even the highest level of outside air, of literally being outside, is not on its own enough to prevent infections from spreading. And overall, I feel like the biggest change that we've seen, and that could come in the future, whether it be COVID-19 or other respiratory viruses or just pathogens in general, is that we need to have these layered approaches to prevention, where, like Kevin said, there is no single silver bullet, whether it be masks or increasing filtration or any of the other mitigation strategies that we have mentioned that are going to prevent infections 100% of the time. But by layering these protections into the same built environments, and again, increasing filtration, wearing masks, increasing outside air percentages, physical distancing, and now, thankfully, with COVID vaccines, we can hopefully dramatically decrease the chances of any one individual contracting COVID-19.
Well, that's great, yeah, and that it's a wonderful demonstration of the viability of science. But batting this straight back to Kevin as the hat-wearing architect, I was going to say
Sure.
Archaeologist, but that'd be wrong. You do with walls. I'm sure that's important. Why were we not running buildings in this way before? Does it take people dying en masse? There were still some very tiny percentage, but some 50,000 people a year dying of flu.
Sure.
Why were buildings not operated in this way? Is it cost?
Yeah. I think it's cost. I think it's awareness that it matters. I would argue that even though we've probably all experienced it, you got sick from the flu, or your kids at school got norovirus. My kids go to a school that had been shut down twice over the first couple of years. I was here with norovirus outbreaks where either the school classroom was shut for a few days or half the kids were missing. So we know that buildings do implicate our health in really visceral ways. But I would just say with the COVID pandemic, it punched us in the face, and it made it so poignant that we couldn't overlook it, to the point where many people are still a year later, still not in buildings, still not congregating together on a regular basis indoors. And by the way, I think because of the state of our building stock, that's essential in many locations. But we have learned a lot over this last year. How I wish we were surveilling our buildings for the presence of viral pathogens a year ago. But guess what? We are now, and more so with wastewater monitoring. We're working on a bunch of air monitoring solutions. I believe within the next year or even sooner, we'll be getting closer to real-time data in situ, the equivalent of viral smoke detectors. Maybe not triggering an alarm to evacuate the building, but instead triggering an alarm to increase the outside air rate, or a variable filtration, or targeted deep cleaning, or even targeted human testing or contact tracing. So I think we're headed there. I believe the technology has been there long enough. We just never had the reason to marry the design and the engineering with the problem, because the problem wasn't painful enough.
I like that. It's got to be a certain degree of pain. I'll say, for one, the pandemic has significantly reduced my pain threshold by stopping me from traveling. And so no conferences, no airports, no planes, and that's been a wonderful experience for me. And I think this comes down to recommendations, right? And Leslie, I'd be if you're organizing a conference, scientific conference, right? And you had to come up with recommendations that were specific to stop disease spread in the conference attendees. What are the three or four simplest things that you would tell them to do?
Well, as Patrick and Kevin have both mentioned, having a well-ventilated building is better. And I would say 3 easy things that you can look at to reduce the prevalence of SARS-CoV-2 indoors is to pay attention to things such as your air changes per hour, which is the ventilation, your relative humidity, and carbon dioxide. By looking at the carbon dioxide levels in an indoor space, you can get an idea of the amount of fresh air that a room is getting. You can then adjust the ventilation according to what you see there. Having relative humidity of between 40 and 60% can reduce the number of suspended aerosols that could contain virus. And also adding something as simple as an indoor HEPA filter would be a great idea. I would say make sure it has a clean air delivery rate, which listed on the box, and you'll see it listed as in capital letters CADR. And you can expect to spend at least 50 cents per square foot.
That's great, right? But then you've got recommendations, specific things like CO2. If you can monitor CO2, you can monitor the humidity, and you can control those variables. And then the air exchange, then that goes a hell of a long way to significantly reducing the potential for burden or for infected burden. I like that a lot. Switching, ASM and M systems generally have been really pushing for early career scientists, and not to dispatch the other two, but I'm interested in Patrick coming out of a graduate PhD working in this space. This paper, this research seems to, as I said in my introduction, shaped your career path. What would you say are the key takeaways that you took from this, and how do you see your career shaping the future of this field?
Yeah, absolutely. So with the emergence of SARS-CoV-2 and this pandemic, it has definitely changed my outlook on the future of my career. And I've become much more interested in understanding the mechanisms of transmission of pathogens from individuals, from not only the purely science or academic side, but also much more from the public health side. And really, I've started to really want to dig into more understanding the structures that have been deployed by modern society and how those lead to individuals' unique microbial exposures. Really, this pandemic has just highlighted a lot of the inequities that exist in our society, and first just through the microbial exposures that we experience. And that's a perspective that I don't see a lot in biology research. And I think it's a dynamic that I want to explore a lot more deeply than I did before the onset of SARS-CoV-2. And to this end, I quickly just want to shout out a group that Leslie and I are both members of called the Microbes and Social Equity Working Group. This group, which was founded by Dr. Sue Ishak, who actually used to be a postdoc here in our lab at the Biology in the Built Environment Center, is made up of over 40 academics from around the world that are working together to examine, publicize, and promote a research program on the reciprocal impact of social inequality and microbiomes. And we're hoping to together influence future research and policy to better address access to resources, access to green spaces, and exposure to microbes and pathogens, and ultimately create a healthier and safer environment for everyone. And being a part of this initiative has become a really important part of my research, and I hope that I can, in the future, blend mechanistic understandings of pathogens with these social factors, and in the future to not only address future questions in the world of microbiology, but to also address societal problems as well.
I think that is incredibly important. The equity divide in this country alone is terrifying and awful in so many ways. And the ability to understand the role of that gulf that exists based on economic availability and availability of resources and its impact upon how buildings are built and operated, I think is something which we need to do. I think we've actually just found our next perspective, and I'm going to charge both of you with writing that perspective. M Systems would love to host that kind of ideology. We actually have coming up on March 26th an M Systems thinking working group on diversity, equity, and inclusion in microbiology. I strongly encourage you both to come to that because I think it'd be great. And I'd like to join that working group as well. It sounds fantastic. Leslie, what are you up to now? Are you sticking with SARS-CoV-2 or are you going to build out this research program into something new and exciting?
Well, I have 2 PhD offers on the table, so I'll be beginning a PhD somewhere this fall.
Congratulations.
Thanks. I enjoy the work we do here. I feel very connected and engaged by it. I feel like it has a great application to everyday life. It's totally applicable to everybody. As we try to return to some level of normalcy at our homes and our work and our schools, this research can serve to inform the public, the policymakers, building designers, architects, engineers, to create and operate spaces that are beneficial to human health. So
I think that is wonderful. So where you're applying, will you be able to keep up that program, or do you want to delve off into octopuses or something else?
I am at a fork in the road. So it'll either be a continuation of this or it will be back to vascular research as I have had done in my past.
Which is SARS-CoV-2 related. SARS-CoV-2 seems to hit everything. You can vascular disease, neurological disease.
That's true.
It will never leave you now. It's with you forever. All right. Just as we wrap up, Kevin, are you doing teaching at all on any of these subjects? Do you, the undergraduates? I know my teaching has changed dramatically due to the video conferencing, but I feel like I seem to wrap SARS-CoV-2 into virtually every lecture.
Yeah, for sure. I'm with you, Jack. So I actually had spring quarter as my quarter off for research last year. And then given the craziness that this year it bled into, I actually juggled the deck. So I had fall quarter off. But I did teach my first class pandemic mode here this winter. Perhaps not surprisingly, the title of the course was Building Health. And I will say we certainly touched on coronavirus. I really tried to limit it to a week or two, though it popped up here and it popped up again there because we also talked about daylighting and we talked about humidification and we talked about healthy materials and indoor air chemistry. And of course, the weave, the tapestry all comes together, which is really sort of what I think the point is. And even Leslie's comment about, a vascular scientist studying the indoor built environment. That's not normal, but it needs to be the new normal. Yeah. So, if I believe in this principle of radical interdisciplinarity, and I'm having so much fun because architecture is a bit of a crucible to all sorts of different expertise and disciplines. And while my training is formally all in architecture. I've spent 15 years of my career effectively trying to become a mechanical engineer, or think and learn and manipulate systems like a mechanical engineer. And then the last 5 years of my career, I've been trying to think like a microbial ecologist or a microbiologist. And the sort of, intense infusion of disparate knowledge has been fantastic. The research in the microbiology in the indoor environment has led to publications and questions that I never imagined asking as an architectural designer or as a building scientist. We published a paper in the Green Journal for OBGYN medicine, and it had to do with microbial exposure during child labor, right? So places that I think are really interesting footholds to start getting disciplines to recognize that we have a lot of big problems to solve. COVID is one of them. In my class, the theme has been COVID, community, and climate. And just to keep it simple, community is trying to represent diversity, equity, and inclusion, and social justice and inequalities, and looking at, when solving a wicked problem like COVID, maybe we actually need to try to solve a bigger problem like diversity, equity, and inclusion, social justice, climate change, and COVID. And if we can pull way back and try to see that problem from that perspective and connect some dots with expertise, with a humble heart and an understanding that we don't always have all the answers, but we can put one foot in front of the other and hopefully make a difference and a bit of an improvement.
Maybe you should go and ask what's going on in New Zealand and Iceland and how they kept it at bay, and South Korea, right? They seem to do a pretty good job working on those. But I really love that ideology, right? We have big problems that need solving, and especially the equity in our society. That is the one thing I could build an entire house out of soapboxes if you get me started. You mentioned, I know I have to wrap up, but I'm just very excited this. You mentioned living materials, right? Building materials that have a living quotient. Can you expand on that a little bit? I'm happy for anyone to do that, but I'm really interested to know what you guys are doing in that space.
Well, I'll be brief. First I'll just talk about natural materials. Just like I talked about natural systems for daylighting and ventilation and humidification, I think materials is another piece of the equation in terms of the surface microbial and chemical interactions, how that may be resuspended into the air we breathe or to the surfaces that we come in contact with. And just trying to understand that there's another layer of activity happening here that so far we've been ignoring, but now with molecular tools, we have the ability to study and understand, how does the decision we make regarding materials or building operations implicate human health in these long-term, maybe long-term chronic factors. And I think the microbiome touches that, but also these acute factors. And certainly with COVID, we know the microbiome touches that. So, my predecessor here at the Biology and the Built Environment Center, Jessica Green's TED Talk says it well, which is we've been manipulating microbiomes in our built environment for millennia without recognizing it. And now we have tools to understand it, and we can design around it toward goals to create more supportive environments. So I remain, on one hand, very skeptical and cautious about intentionally manipulating the microbiome, but at the same time, I'll also recognize we have been just unintentionally manipulating it. So let's learn as much as we can and try to do it smart with avoiding unintended consequences as much as possible.
Oh man, I could go deep in that. I've got some research ideas, or I'd be really excited to work with you guys on that. All right, I have to finish though. Thank you so much. I really appreciate this opportunity to discuss it, and this was great. And thank you for considering M Systems as a venue for this really cool paper, because it was epic, literally. Thank you guys, much appreciated.